Okay, so in this discussion, I'm going to go over dead zones and eutrophication. So I posted a picture here in the top right. I want to just, if you take a minute and think about what could this possibly be a picture of. So you can see a little shoreline here, and there's a seagull. So I could say what's wrong with this picture, I guess. And the problem here, clearly there's a green tint to the water. And so this is actually a picture of Lake Erie. I think it's from around 2014. Lake Erie, which is up, in the northern United States near Ohio. And this came from an article from the New York Times in 2014, detailing how toxic algae had grown in Lake Erie, and how this is actually a really common problem all over the world, actually. But this was a particular problem for the city of Toledo, which is, I think, like 200 or 400,000 people. So they get some of their drinking water from Lake Erie, and this algae that was growing was toxic. So it's called, I think, myoticin. Basically, it can cause like vomiting, diarrhea, and all kinds of stuff. So they shut off the whole city's water supply for a couple of days because it was toxic. Literally, their water supply was toxic. So this is not all going to be about Lake Erie and Toledo. As much as I care for the citizens of Toledo, this is a problem that happens all over the world, and it's related to this phenomenon called eutrophication. Okay, so we have eutrophication, which is eutrophication just refers to when there's an excess amount of nutrients in the water. Okay, it's the algae itself are not. That's not eutrophication per se. Eutrophication is caused by this excess. Eutrophication is the excess nutrients in the water, which then causes the algae to grow excessively. And so usually the cause of this, the main cause of eutrophication, is it's usually excessive runoff from fertilizers from farms. So if you think about it, why do farms add fertilizer to their crops? Because it helps the plants grow. So if those same chemicals, mostly nitrogen and phosphorus, imagine like you dump a bunch of this on a farm field and you want it to, just sort of like integrate into the soil. There's other issues with this as we've discussed, but it does help the plants grow. So what if a rainstorm comes by, pulls the, you have some runoff from the rain, and that pulls the nutrients with it, and then of course it drains into the local water system, which then drains into the other bigger water system, and so forth. And so what ultimately happens is, because you have these chemicals that help plants grow, if a whole bunch of them end up in the water, what are algae? Algae are plants. They're photosynthetic. So these nutrients are like, it's just like a bonanza for these algae. So they have everything they need at the top of the water. They have a bunch of nutrients, they have sunlight, and they have water. Like, that's what plants need to grow, and so that's why you have these excess algae blooms. So the eutrophication is just the excess chemicals that end up in the water. Okay? And as I said, that leads to this abundant growth of surface-dwelling algae, which is bad because, number one, in this example here, and this happened down in Florida. It happens every year in Florida, where they have these like nice beach communities, and they have the toxic algae that end up kind of really ruining the tourist, like the attractiveness of the area and so forth. So it's toxic, which can kill farm animals, it can kill people, it can make people sick, but it also causes dead zones, which we'll talk about here in a minute. So that's eutrophication. It's just the excess nutrients in the near the surface of the water, which then can lead to other things. And one of the big ones is a dead zone, and as detailed in the videos and readings, a dead zone is this area of water that's very low in oxygen. It's what's called anoxic conditions, and it ends up near the bottom. And here's a little illustration of it, and I'll just explain the process here. So the process is, you have excess algae on the top, this big algae bloom, right? So like we saw in that picture. That itself, I mean, if they're toxic, that's bad. I mean, excess algae, it's not great, but the algae themselves don't cause the dead zone on the surface, okay? The problem is when the algae die, they sink to the bottom, okay? And that's not even a problem yet. The problem is the microorganisms that eat the dead algae, okay? A byproduct, so those microorganisms remove oxygen from the water. So the algae up here, they die and they sink down to the bottom, and that's not necessarily a bad thing. But then you have these organisms that eat these algae, and those organisms, they breathe oxygen. So they remove oxygen from the water just because they're alive and they're thriving because they have all this food, and they release CO2 into the water. So what happens is the water down near the bottom is going to be low in oxygen because there's all these organisms that are pulling oxygen from the water. That's obviously a problem because a lot of organisms live near the bottom. Think of your shellfish and so forth and other, bottom dwelling organisms. And they are used to having oxygen in the water, and if there's lack of oxygen, then they'll vacate the premise, right? They'll just leave, or they'll die. And so if you think of like shellfish industry in the Chesapeake Bay, for example, out here on the East Coast, oysters and clams and so forth, they all live on the bottom and they all breathe oxygen. So when this oxygen, if there's not enough oxygen, it decimates the population of those bottom dwelling shellfish, right? So that's an issue. That's a big problem, and that's your dead zone. Your dead zone is an area where there's very little oxygen in the water and it's near the bottom. So these are all over the world. The sort of most infamous one in the U.S. is the Gulf of Mexico, and here's a picture of the Mississippi Delta, right? So New Orleans down here, and here's this dead zone, and it forms every year, right around the same time, like mid to late summer. It's currently every year. It's around the size of New Jersey. Big deal, right? This is huge. And if you know anything about the Gulf of Mexico, it's a huge shrimping industry down there. There's some oysters and clams and so forth. I mean, they're famous for all that stuff down there, and they supply a lot of the of that, like the shellfish in the United States. So this is a problem, right? Major problem for tourism. It's a major problem for fishing. And then you throw in a few like toxic algae blooms here and there, and it's just bad for people, bad for animals, and bad for everything. And so if you think about why would the Gulf of Mexico have a huge dead zone, like it's the biggest one in the U.S. If you think about the causes of it, so think of this from a systems perspective. So if you have your Mississippi Delta down here, right? And this picture, so here's the United States. Okay, you can see the United States here. So, and this is the area that's colored in. So this colored area all drains toward the Mississippi River, which flows down through here, right through the middle, almost like a funnel. You can think of it. So all of this stuff, this is called a watershed, and the watershed all drains toward the Mississippi. This drains, this drains, this drains. Everything sort of funnels into the Mississippi. And if you look, the color coding on this picture, you see the light green here, which is the vast majority of the land area. That's mostly agriculture land. Well, remember what causes eutrophication? Runoff from farms. So most of this, so like 40% of the United States is in this Mississippi River watershed. And this is, from about 5 years ago or so, probably like 2016, 2017. About we'll round it up, 2 million tons of fertilizer end up in the Gulf of Mexico each year. Why does it end up in the Gulf of Mexico? Because you have all these farms that add all this fertilizer, and then the rain, it runs off into the local stream, which then runs into a bigger stream, which then runs up into the Mississippi. So that's why that's why eutrophication happens. It's not like, you can have eutrophication in like a little pond on your property or whatever, but the really big problems are when you have all these streams that have runoff from farms and they run into bigger streams and rivers, and then they dump into a body of water like the Gulf of Mexico. And so that's why the dead zone happens in the Gulf of Mexico every year. Why does it happen in late summer? Because a lot of the farming is done in like the late spring, early summer. So by the time, it takes a while to filter down. By the time those excess nutrients reach down here, it takes, a couple of months, and then it's like you just have this huge dead zone. Okay, so that's an explanation of eutrophication and dead zones. And keep in mind that it's not just the Gulf of Mexico that's a problem. There are hundreds of these dead zones across the world. In every country, it's a problem. So it causes the same sort of issues everywhere you go.